replacement sets. Now, a replacement set is the set of possible values for the variable. So, braces like these, and I can't draw them real well, so just do the best you can, are used for the notation. So, basically, a replacement set could be all real numbers, or it can be integers, or it could give you just a set of numbers. Now, your solution depends on the replacement set for the variable. To find the solution, you need to replace the variable with each number of the replacement set, selecting only the values that satisfy the inequality for your solution. And these are always going to be with inequalities. Alright, so let's look at some examples. Okay, this first example, negative 5x is greater than or equal to 12. Our replacement set is going to be the real numbers. So you need to first solve this. I subtract 5 from both sides, or excuse me, I divide each side by negative 5. Notice I flip my sign. I get x is less than or equal to negative 2 2/5. Now since it's all real numbers, it's basically just like what we normally work with. So my solution is going to be all real numbers less than or equal to negative 2 2/5. So to graph it, I put a closed dot on negative 2 2/5, and then I go to the left showing it's all numbers less than that. Now this next one, 2 times the quantity of a minus 2 is greater than or equal to 3. Now it's saying my replacement set this time are integers. Remember, positive and negative whole numbers. So first thing I need to do is solve this. So 2 times a is 2a. 2 times negative 2 is negative 4. Okay, so now I have 2a minus 4 is greater than or equal to 3. Now I need to add 4 to both sides. I get 2a is greater than or equal to 7. Then divide each side by 2 and I get a is greater than or equal to 3.5. Now my solution is going to be all integers greater than or equal to 3.5. When I graph it, I need to put a dot on all the integers. Now I can't draw a line because of the fact that the numbers between 4 and 5 are not integers. They're rational numbers, but they're not integers. So I cannot put a dot on negative 3.5 because that's not an integer. That's just a rational number. But the next rational number larger than that is 4, then 5, then 6, then 7, then 8, then 9. Notice they're just little dots. And I do 3 little dots down here to show that it'll keep going on and on. So I've only put dots on the solution set, which are integers, not in between. This third one, I have 3x plus 3 is greater than 7. Okay, my replacement set this time is a group of numbers. Negative 2, 4, 8, and 12. So I need to solve this inequality first. I subtract 3 from both sides. I get 3x is greater than 4. Then I divide each side by 3 and I get x is greater than 1 1/3. Okay, now my solution are going to be the replacement set numbers that make this inequality true. So negative 2, is negative 2 greater than 1 1/3? No. So that's not an answer. Is 4 greater than 1 1/3? Yes, so 4 works. 8 is also greater than 1 1/3, and so is 12. So 4, 8, and 12 are my answers. So when I'm graphing it, all I need to do is put dots on 4, 8, and 12. And that's it. Alright, now let's look at an application problem. So I have the length of a rectangle is 20 centimeters. For a perimeter of, at most, 48 centimeters, what is the width of the rectangle? Well, we know we don't measure in negative numbers. We only measure in positive. So my replacement set for this inequality is going to be positive real numbers, no negative numbers. Okay, so remember your perimeter equation is 2 times the length plus 2 times the width. So that's what I have here. It's going to be at most 48, so less than or equal to 48. I know my length, so 2 times 20 is my length of both lengths. And then I don't know my width, so I leave that as w. So 2 times 20 is 40. 40 plus 2w is less than or equal to 48. Subtract 40 from both sides. I get 2w is less than or equal to 8. Now divide each side by 2 and I get W is less than or equal to 4. Now, when we were talking before in the beginning of the problem, we said that the replacement set was positive real numbers. Because I can't have a width of -2 or -4 or even 0. Because if I had a width of 0, I'm not going to have a rectangle, I'll have a straight line. So, in order to find our solutions, we're going to put an open circle on 0 because it can't equal that. None of my negative numbers are going to be a solution. 4 can be a solution, so I have a closed dot on 4. And a solution can be anything less than 4, but remember, it has to be greater than 0 because I can't have a negative number. It's a distance. So, my answer is going to be 0 is less than W, which is less than or equal to 4. It's basically saying that my lengths can be between 0, greater than 0, and 4.